Welcome to Lesson 2-1, Perfect Squares and Square Roots. Today we're going to talk about how to find the square root of a number, identify perfect squares, find the square of a number, and estimate the square root. So make sure that you're paying attention here because we talked about finding two different things, the square root and the square. Those are both different things. So when we talk about this, I want to reference the fact that it says square. And we know that squares have sides that are the same length. So sides are, we'll just go ahead and say equal. So I want you to keep that in mind when we're talking about squares and square roots. All right, so definitions. We have a perfect square. A perfect square is a number that is the solution to an integer to the second power. We can also say an integer that is the solution to a number times itself. So we'll just put or a number times itself. Okay. So the perfect square in this case, so I know that 4 times 4 we write as 4 squared. And that this is actually equal to 16. 16 in this case would be the perfect square because it is the answer to 4 squared or to 4 times 4. The square root then, so we're going to take a step back, the square root is the inverse or opposite of squaring. It's what we do to undo squaring. And the symbol for that looks like this. It's called a radical symbol. You're going to want to make sure that you have that. So in this case, if I wanted to know the square root of 16, I know that 16 is equal to 4 squared. And what that means is the square root undoes the square. So then the square root is 4. So it's not 4 times 4 that's the square root, it's 4. It's what one number does 16 come from when it's an answer to the multiplication problem. So what one number gives you the product of 16 when you multiply it by itself? In this case, that would be 4. All right, so square numbers. We talked about perfect squares. So perfect squares, so let's take a look at 2. So here's 1 square and here's 2. It doesn't make a perfect square because you have 1 by 2. No matter how you do it, it makes a rectangle because the sides aren't the same length. Same thing with 3. I can do 3, but it's still 1 by 3, or 1 by 3, or I can even, I'm going to use my pen for this, I can even go 1, 2, now I've used 3 squares. Still doesn't work. I still don't get a square. So I can't do it with 2. I can't do it with 3. And with 4, I can look at it and go, okay, 1, 2, 3, 4. But that doesn't work. But if I rearrange, so you want to rearrange and try to make a square. But with 4, I can because I can do 2 blocks over here and 2 blocks over here. So it's 2 by 2. And we know that with a square, when you're finding the area on the inside, which in this case is 4, you do 2 times 2. Well, this is what we just talked about. We talked about perfect squares being the answer to a number squared, which is a number times itself. So again, perfect squares are called perfect squares because they actually make a square. So basically what you're saying is if I have 4 units, or let's just say 4 blocks, if I have 4 blocks and I put them together, can I make them into the shape of a square? If I can, then it is a perfect square. If I can't, it is not a perfect square. And then the square root of that perfect square is whatever my length and my width are. Okay, so in this case, a square that has 3 by 3 has 3, 6, 9 units on the inside. A square that's 4 by 4 has 4, 8, 12, 16 units on the inside. 5 by 5, 5, 10, 15, 20, 25. And 6 by 6, 6, 12, 18, 24, 30, 36. So notice there's not really this set in stone way to go from one to the next, but all of your numbers are the same from side to side, because to make a square, we know all sides have to be equal. And so even though I can take different numbers and multiply them to get 16, I could take 8 times 2, but that would be 8 units this way and 2 units this way, which is a rectangle. So yes, that's a different way of getting it, but since it's not a square, that's not the square root. It's when your numbers are the same on both sides. Okay, so when it's 4 blocks by 4 blocks, that is going to be your square root of 4. And 16 is the number of blocks you need to make that perfect square. And to do that, you have to put them in a 4 by 4 configuration. Okay, so again, the perfect squares in this case are 9, 16, and 25 because they are what you get. So it's like the area of your square. So 9, 16, 25, those are the number of blocks you would need to make a perfect square. And again, this goes higher and higher and higher. And there's an infinite number of ways to do it since there are an infinite amount of numbers. So when we're trying to find the square root of a number, you use the radical sign. So the square root is what undoes squaring. So we know that squaring is when you're to the second power. So to undo, square root undoes the exponent of 2 to the second power, or the squared. Okay, so again, the square root symbol is, so this is a symbol for square root. It's called the radical symbol. And then we know that you read this by saying the square root of 81. And then in this case, 81 is the number of squares that there are. So it's the area of the inside of the square. If we were to draw the square, so area of the square. Okay, so it's that inside, so it's 81 little squares, and the square root is going to help us find these numbers. So square root helps us find our side lengths. So what this means is, and I can't click on that, there we go. What it's asking you to find is how big are the sides if my square has 81 little squares inside of it. How big are my sides if the area is 81? Okay, so if my area is 81 and I draw a picture of this, I know that I end up being 9 by 9. Well, in order to do this without drawing a big square every single time, which is what we would like you to be able to do, you have to know your multiplication facts. And so you have to practice those. And I can show you some techniques to work on guessing and checking to get the correct answer, so that way in time they come quickly to you. All right, so the square root of 100. This is typically an easy one for us because we know that to get to 100, you should do 10 times 10. Okay, we could also do 20 times 5, but since these numbers aren't the same, that's not what we use for the square root. That doesn't really help us out at all. So I'm actually going to put that on here because it's something that I think would be important to write down. So does not work because your numbers are not the same. So they would give you different side lengths, which means that the shape that it would make would no longer be a square. So, and I'm actually going to type this out to make it a little easier to see. So this right here is read as the square root of 100. And what it means is that there is a square with 100 little squares inside it, or there is a square with the area of 100. So there is a square with the area of 100. Since it's a square, I know that both sides have to be equal. So length has to equal width. And so I know that 10 times 10 gives me 100. So I know that that means 10 squared, and I know that the square root undoes the squared exponent, so that gives me 10. So essentially what you're looking for is what times itself gives you the inside number. And yes, it's 10 times 10, but we want the square root. So to help you know that it's just 10 and not 10 times 10, root is singular, so your answer should be one number. All right, well, now what happens when you have a number that's like this? When you look at the square root of 46, if you know your multiplication facts, you know right off the bat that this doesn't work. And I don't want to say that there's not an answer, but there's not an answer that's going to have an end. It's going to give you a decimal that goes on forever, which we know is an irrational number. So what we do is we say, okay, what number or what two perfect squares is this in between? So I know that 46, well, I'm going to start looking at something I know. I know 5 times 5 gives me 25. So 25 is a perfect square, but it's too small. So then I'm going to go to 6 times 6, which is 36. So it's not going to be between 5 and 6 because 36 is on the small end and I need something that's bigger than 46 now. So I look at 7 times 7, which gives me 49. So I know that 46 is between these. So the square root of 46 is between, now we're looking between what two perfect squares. So the square root of 46 is between these two perfect squares. So if I were putting them from least to greatest, it would be like this. So what this means is the square root of 46 has to be between the square root of 36, which is 6, and the square root of 49, which is 7. Okay, so when you're estimating, you're just telling me what is it between. So the square root of 46 is between 6 and 7. Okay, so then what you would say is the estimated square root would be, and I will again type this so it's easier to read, between 6 and 7, and it'd be closer to 7. Now, it's closer to 7 because 46 is closer to 49. So that means its square root is going to be closer to whatever the square root of 49 is. So the square root of 49 is 7, so the square root of 46 is going to be closer to 7. Don't worry, we'll get some practice with these. So let's go through and try some examples. So the square root of 4, I know that 2 times 2 gives me 4, so the square root of 4 has to be 2. I know that 10 times 10 gives me 100, so the square root of 100 is 10. I know that 3 times 3 is 9, so the square root of 9 is 3. And then now when I'm working with fractions, what I have to look at is each piece of the fraction. So I'm basically looking at the top and the bottom. So I know that 1 times 1 gives me 1, and that 2 times 2 gives me 4. So in this case, the square root of 1/4 is 1/2, and you can double check that by multiplying 1/2 by itself, and you get 1/4. And I know that 1 times 1 gives me 1, so the square root of 1 is 1. And then here, again, you just split it into top and bottom. So 4 is 2 times 2. 16 is 4 times 4. So the square root is 2/4. Now, we do not simplify this. And the reason being, if I simplify this, it goes down to 1/2. But 1/2 squared is 1/4, not 4/16. So do not simplify. Okay, so here 2 squared means 2 times 2, and I'm only going to do this once, which is 4. So 2 squared is 4. 5 squared is 25. Again, practice it. If you don't know, write it out. So 12 squared, we typically know 12 squared. I don't know what it is about this number, but we all like to know that 12 times 12 is 144. And then if you're not sure, so here we have 13 times 13. Write it out. Do the math. Practice it. So 3 times 3 is 9. 1 times 3 is 3. Done with the 3. 3 times 1 is 3. 1 times 1 is 1. So I get 9, 6, and 1. So 13 squared is 169. Here, again, you're doing 3/5 times 3/5. And we know to do that, you multiply straight across. So you get 9/25. And here I would get 1/3 times 1/3 is 1/9. Again, these should start to come more naturally to you as time goes on. If you need to, while you're working on these, test it out, try it, show the work, and then in time, your perfect squares, I would expect that your perfect squares from like 1 to 15 should come easily to you. So here we have 65. Well, I can do a couple of things here. I know that 10 times 10 is 100. So I know that it has to be, whatever it's between has to be less than 10. And I know that 9 times 9 is 81. So I'm still going down. So it's not going to be between 10 and 9. Again, we just continue to guess and check. I know 8 times 8 is 64, and I know 65 fits right between there. So again, my estimate is that the square root of 65 is between 8 and 9, and since 64 is closer to 65, that it's closer to 8. So here, I know that 10 times 10 gives me 100, so it's going to be bigger in this case. 11 times 11 is 121. So this is how you guess and check. Use the ones that you know. I know 10 times 10. I know 5 times 5. Those are right off the top of our head. We know those multiplication facts because they're nice and simple for us. Now I know that it's not between 10 and 11 because 135 doesn't fit here. I know my next one, 12 times 12, is 144. And so I know 135 fits in between there. So then I know that my estimate is between, that the square root of 135 is between 11 and 12. And if I'm not sure, I do the math. 135 minus 121. Those are 14 spaces apart. And 144 minus 135 is 9. So it's closer to the 144. So the estimate is going to be closer to 12 because the 135 is closer to the 144. All All right, here I know 5 times 5 gets me to 25. So I know I have to go lower, which is 4 times 4 is 16. I know the 21 fits in between there. So now here, I know that my estimate is going to be that it's between 5 and 4. And now here, 25 minus 21 is 4. And 21 minus 16 is 5. So ever so slightly, it's going to be closer to the 5. Or we could even say it's probably going to be closer to 5 or 5.5, since it is so close together. So because the difference between the 25 and the 21 and the 21 and the 16, because it's so close, it's probably going to be closer to halfway than it is to either one of the numbers. All right, so you have some problems here to try on your own. Again, take your time, write it out, whatever you need to. Go slowly, because this is just the base of what we're going to be getting into in the future. Make sure that you are double checking your work if you need to. Double check with the multiplication chart. And as always, if you have any questions, email me or write them down so we can go over them in class.